Okay, this is section 2.2, which is basic differentiation rules and rates of change. The first rule is the constant rule. The derivative of a constant function is 0. That is, if c is a real number, then d over d of x of c equals 0. And then this is the proof. So if f of x equals c, then by the limit definition of the derivative, d over d of x of c equals f prime of x. So as the limit of delta x approaches 0, f of x plus delta x minus f of x all over delta x equals the limit as delta x approaches 0 of c minus c over delta x equals the limit as delta x approaches 0, which equals 0. The next rule is the power rule. If n is a rational number, then the function f of x equals x raised to the n is differentiable, and d over d of x raised to the n equals nx raised to the n minus 1. For f to be differentiable at x equals 0, n must be such that x raised to the n minus 1 is defined on an interval containing 0. Then this is the proof. If d over d of x raised to the x to the n equals the limit as delta x approaches 0 of x plus delta x raised to the n minus x raised to the n all over delta x equals limit as x approaches 0 of x raised to the n plus nx raised to the n minus 1 times delta x plus n times n minus 1 times x raised to the n minus 2 times delta x raised to the 2 plus, and it keeps going, all over delta x. Then, the limit as delta x approaches 0 of the quantity of nx raised to the n minus 1 plus n times n minus 1 times x raised to the n minus 2 times delta x, and then it continues, plus the quantity of delta x raised to the n minus 1 all over 2. Then n of x raised to the n minus 1 plus 0, and then it continues plus 0, equals nx raised to the n minus 1. So that's the proof. The next rule is the constant multiple rule. If f is a differentiable function and c is a real number, then c of f is also differentiable, and d over d of x with the quantity of c of f of x equals c of f prime of x. And this is the proof. If d over d of x times the quantity of c f of x equals the limit as delta x approaches 0, c of f times the quantity of x plus delta x minus c of f of x all over delta x equals limit as delta x approaches 0 of c times the quantity of f of x plus d of x times delta x minus f of x all over delta x equals c times the quantity of the limit of delta x approaches 0 of f times the quantity of x plus delta x minus f of x all over delta x equals cf prime of x. So that's the constant multiple rule. The next rule is the sum and difference rules. The derivative of f plus g, or f minus g, which would be the difference rule, is the sum or difference of the derivatives of f and g. The sum rule is d over dx is f of x plus g of x equals f prime of x plus g prime of x. The difference rule is d over d of x times the quantity of f of x minus g of x, which then equals f of x minus g prime of x. And then this is the proof. So, if d over d of x times f of x plus g of x equals the limit as delta x approaches 0, f of x plus delta x plus g of x plus delta x minus f of x plus g of x. as delta x approaches 0, f of x plus delta x plus g of x delta x plus delta x minus f of x minus g of x. The limit of delta x minus 0 is the quantity of f of x plus delta x minus f of x all over delta x plus g of x plus delta x minus gx over delta x, which equals the limit of as delta x approaches 0, f of x plus delta x minus f of x all over delta x, plus the limit of delta x as delta x approaches 0 of g of x plus delta x minus g of x all over delta x. The difference rule can be proved in a similar way, so I'm not going to prove that. The next rule is the derivatives of sine and cosine. So, as the limit of delta x approaches 0, sine of delta x over delta x equals 1. And the limit of delta x approaches 0, 1 minus cosine delta x over delta x equals 0. And this is the rule. So if d over dx of sine of x, the derivative of that is cos x. And d over dx of cos x is negative sine x. Last and final is the rates of change. So v bar equals delta x over delta t. The v instantaneous is dx over dt. So basically what this means is the average rate is the average slope of a function, and instantaneous rate is the derivative of a function at a certain point. So now, since I just went over all the rules for this section, I'm going to go over a few problems for each. The first is the constant rule. So we're going to find the derivative. So this is pretty self-explanatory because based on what I went over, the derivative of a constant is always 0. So we have 2, 5, 7, 6, 4. Obviously they're all 0, so that's pretty self-explanatory. Next is the power rule. So the power rule, we have a few examples. We have x squared, x cubed, 3x sixth, x4, x12. So x squared is 2x. Bring the 2 over, subtract 1. So it's 2x, bring the 3 over, subtract 1, 3x squared. And then the rest, 6 times 3 is 18, minus 1 is 5. 4 times 1 is 4, minus 1 is 3. 12 minus 1 is 11, so we have 12x to the 11th. So this is the constant multiple rule. So basically what the constant multiple rule is you take, so this one is 5x. So you take 5 times the derivative of x. So since the derivative of x is 1, 5 times 1 is 5. So 5 times 2 is 10. 6 times 3 is 18, because the derivative of these, 6 times 3 is 18 squared, because the derivative of this is 3x squared. So you do 6 times 3x squared, which is 18x squared. So this is pretty self-explanatory. Okay. So sum and difference rules, pretty self-explanatory as well. So if we have 2x plus 3x, we get 5. 3x minus 2x, we get 1. 4x minus 4x, 0. 3x plus x, we get 4. 4x plus 2x, we get 6. Okay. So the second to last one sorry, I did this in the wrong order. So sine and cosine. So these two are basically the rules that I discussed earlier, just to like reiterate that. But then, so if I have 3 sine x, the derivative of sine is cosine. So it's going to be 3 cosine x. But then for the derivative of cosine would be negative sine. So this is going to be 2 cos x equals negative 2 sine x, because you bring the negative in front. Okay, so that is it for the basic differentiation rules and rates of change.